Hello, algebra students. Today we're going to be looking at graphing parabolas, specifically axis of symmetry, the vertex, and comparing the width. So our first learning target, we're going to be able to determine the axis of symmetry and the vertex. Okay, and when we're looking at the vertex, we should be able to tell the maximum or the minimum of that parabola. And we're going to do all that mathematically. Our second learning target, you'll be able to compare quadratic functions and determine which parabola is narrower or wider. Okay, so let's go ahead and move to the next slide and specifically focus on these two things. All right, so we're going to look at vocabulary on this slide, and some of this we've already dealt with, so this is a review. You should already know what a quadratic function is. It's nonlinear, of the form that forms a symmetrical U shape or an upside down U shape. The standard form of a quadratic function is f of x equals some number, which we're going to call a times x squared, plus some number we're going to call b times x, plus another number c. Okay. It could also not be written in function notation, so it could also say y equals a times x squared plus b times x plus c. All right, our parent function of a quadratic is f of x equals x squared, or obviously y equals x squared. That is the parent function. Then we have a parabola. A parabola is the shape that a quadratic takes when you graph it. So it's what it looks like. It's U-shaped, and it could be inverted, upside down. All right, I'm going to skip over the yellow box, and I'm going to go to x-intercept. The x-intercept is the roots, the zeros. It's also where the parabola crosses the x-axis. And then we have the y-intercept, and that is where the parabola crosses the y-axis. Okay, the important part for today's lesson is the two definitions in yellow. Your axis of symmetry, it is a vertical line that divides the parabola into two congruent halves. We can get the vertex from the axis of symmetry. Okay, now the vertex is the point where the graph changes direction. The vertex is a maximum if it is the highest point, and it's a minimum if it's the lowest point. Okay, and we'll investigate those in the lesson as we move along. So the axis of symmetry is a vertical line that divides the parabola into two congruent halves. The two halves form mirror images of each other. So if you can imagine it split down the middle, they're exact opposites of one another. Okay, it can be calculated by using the formula x equals negative b divided by 2 times a. So we can calculate the axis of symmetry if we are given, or we can simplify into the standard form of a quadratic equation, which is a times x squared plus b times x plus c. If we can get it into this form, we can take the parts and substitute them into the axis of symmetry formula and get our axis of symmetry. So let's go ahead and do that in the following example. Given the function f of x equals x squared plus 4x plus 4, what is the axis of symmetry? So since this quadratic is already in its standard form, let's go ahead and look at the pieces. So our b equals 4, we get that from right here, and our a equals 1. Notice there's appears to be nothing being multiplied by x squared, but that is actually a 1. So to substitute those into our formula, we get this x equals negative 4 divided by 2 times 1. Oh, wait, why is that 4 a negative? Because in our formula, we take the opposite of b. So since our b is positive, we take the opposite. And from that, we get negative 4 divided by 2. Sorry, that's x equals negative 4 divided by 2, which gives us x equals negative 2. And this is our equation for our axis of symmetry. And we know from prior units talking about lines that our axis of symmetry at x equals -2 is a vertical line at x equals -2. And we'll see that on the next slide. So let's move on. So from the prior slide, remember that our axis of symmetry is x equals -2. Well, what exactly does that mean? If we look at the graph over here to the right, we see the graph of a parabola, and this parabola actually is x squared plus 4x plus 4. And you can see that there's a line, a dark black line, right here that divides this parabola in half. And that is our axis of symmetry, and it is at x equals -2. Okay, now how did we graph this? Well, we just took our quadratic and we substituted points into it. So we substituted -2 into it and got 0. And I noticed that that's where it touches the x-axis. So that is actually our vertex. It's our x-intercept, okay, but it happens to be the lowest point of this parabola. So we get a vertex at -2, 0, which I highlighted in pink right here. And we also see that our axis of symmetry is at x equals 2, which I've highlighted in yellow right there. Okay, so we get our axis of symmetry in 3 different places. We see it in our formula that we calculated up at the top, up here. And we see it in our table right here. And we also see it in our graph right here. So that's our axis of symmetry. It also tells us in pink our vertex right here. Now this vertex happens to be a minimum because it's at the very bottom of the parabola. All right, just a quick video on this slide that tells us that we need to watch another video. So we can tell a quadratic, when we have one in standard form, we can tell how wide that parabola is going to be by analyzing the a value, the number that's being multiplied by x squared. So watch this video, and it gives you a great demonstration, a visual of how the number that's being multiplied by x squared, the a value, determines the width of the parabola. Okay, so I'm going to look at 3 examples of calculating the axis of symmetry, coming up with the vertex, and then whether or not it's a maximum or a minimum value. So let's look at example 1, which is 2x squared minus 4x minus 1. So remember, our axis of symmetry formula is -b over 2a. So we have to take the opposite of b. Well, our b in this case is -4, so we were going to take a -4, and we're going to divide that by 2 times our a value, which is 2, and all that to get our formula x equals a number. All right, so the numerator, what we're doing is we're multiplying -1 times -4. So that gives me -1 times -4 is +4. And 2 times 2 is also +4. So that gives me x equals 1. This is the equation for our axis of symmetry, x equals 1. So now we need to find the vertex. And to find the vertex, we need to realize, okay, that we're going to take our x equals 1 and we're going to substitute it back into our quadratic. So when we do that, that will tell us where our x is 1 and our y is at the very bottom. It's going to tell us where the vertex is by telling us where it changes directions. So I've substituted into our quadratic. Now let's go ahead and calculate it out. So 1 squared, this term of the quadratic needs to be done in order of operations sequence. So we have to square it first because exponents come before multiplication. So 1 squared gives us 1 times 2 gives us 2. Minus 4 times 1 gives me 4. And we're going to subtract 1 from that. And again, this is going to give us our y coordinate. So 2 minus 4 is negative 2. Minus 1 is negative 3. So y equals negative 3. So our vertex is at 1, negative 3. Then remember that our maximum or minimum is going to tell us whether that vertex is at the very bottom of the parabola or at the very top of the parabola. This is determined by the sign of our a value, which is 2 in this case. So it's positive, which means that this is a minimum. So I'm going to move on to the next slide and give you the answers. All right, so we came out with x equals 1 for our axis of symmetry. Our vertex was at 1, negative 3. And since this is a parabola that's U-shaped, the vertex is at the very bottom of the U, so that means that this is a minimum. So we've got y equals x squared minus 6x plus 8. Our axis of symmetry formula is right here. Negative b equals 2a. So let's go ahead and substitute in. So we've got negative. Our b is negative 6. And we're going to divide that by 2 times our a, which is 1 in this case. So we've got negative 1 times negative 6, which is positive 6. And we're going to divide that by 2. So we get x equals 3 as our axis of symmetry. And since x equals 3 is our axis of symmetry, we just need to substitute that x value into our quadratic to come up with our vertex. And when we work the operations out, we've got 3 squared, which is 9, minus 6 times 3 is 18, and plus 8. So we got 9 minus 18, which is negative 9, plus 8, which is negative 1. So my vertex is at 3 for my x value and negative 1 for my y value. So we have x equals 3 as our axis of symmetry, and we have 3, negative 1 as my vertex. Now, remember, we have to look at our a value right here in front of the x squared to see if it's a max or a min. It's positive, so that means this is at the bottom of the parabola, which means this is a minimum as well. Let's look at example 3. So we're going to take the values out of our quadratic. We've got negative b. Well, b is 6, so that means negative b is negative 6 times 2 times a. 2 times a. Well, a is negative 3. So this is x equals this, which gives us x equals negative 6 divided by, negative 6. So our x is equal to 1. That is our axis of symmetry, x equals 1. Now, to get our vertex, we're going to substitute our answer for our axis of symmetry back into the quadratic. So our axis of symmetry was x equals 1, and then we're going to solve for y. So our y equals negative 3 times 1 is negative 3, plus 6 times 1, which is 6, plus 2. So our y value in this case is going to be negative 3 plus 6, which is positive 3, and plus 2 gives me 5. So our vertex is going to be at 1 for our x value and 5 for our y value. So for example 3, our x equals 1 for our axis of symmetry, our vertex is at 1, 5. Now, I'm looking at my A for this quadratic, and I noticed it's negative, which means that our parabola is inverted, which means the vertex is at the top of the parabola, which means that it is a maximum. Now, which parabola is wider is going to refer back to slide 5. There was an extra video that talked about how you determined which parabola is wider and why it is wider. So let's look at example 4. Now remember, the larger the number that's being multiplied by x squared, the narrower or the thinner the parabola is going to be. So really you just need to look to find the larger of the numbers so that we can tell which one is narrower. Now the question isn't asking which one is narrower, it's looking at which one is wider. So the larger number is narrower, 10 is narrower, which means that this is the wider parabola, y equals 3x squared. All right. Which of the given parabolas is wider for example 5? Negative 4x is further away from 0. Y equals negative 2x squared is closer to 0. So this is the wider of the two parabolas. It is closer. The number 2, negative 2, is closer to 0 than negative 4. And of course, you can verify these on the Desmos graphing calculator. All right, so for the last example 6, we've got 12x squared on the left and negative 2x squared on the right. So I want to know which one of these is closer to 0. Negative 2 is closer to 0, so it is the wider of the two. So your comparison is just which of the numbers is closest to 0, that's your widest. Which is further away from 0, that is your narrowest. And now it's your turn. So you've got 3 problems. Each problem, problem 1 has 3 questions. Problem 3 has 3 questions. Problem 2 just wants you to put the parabolas in order, okay, from narrowest to widest. So you just need to put those in order. All right, if you have any questions, feel free to check with one of your teachers or one of the algebra teachers. You can check with yours, or you can check in to academic coaching with any of us, and we'll be more than happy to help you out. All right, everybody, have a great, great, great day.